Hi everyone, this video is going to go through experimental probability only. We're just going to do short little sections for this so you don't get too confused, as probability can be very wordy. So experimental probability is very much the same as theoretical probability in that it's found using the same formula. So you can see the experimental probability is the number of favourable outcomes, or the number of things we want to happen, over the total number of trials or the total number of outcomes or total number of events. So it's calculated pretty much the same. The main difference between the two is that theoretical probability goes off numbers and what we would expect to happen. So if we rolled a dice, we would expect the number 2 to have a 1 in 6 chance of occurring. Because there's 6 numbers on the dice, there's only 1 2, so we would expect a 1 in 6 chance. Okay, in this experiment though, they rolled a dice 100 times and they got 43 number 2s doing that. So you can see there that they're different in this case. Now that might be for a number of reasons. It might be, I don't know, the table is slopey or the dice is weighted. It doesn't happen as much, it doesn't vary, sorry, as much with things like this. But later on we'll look at an example which talks about people and their preferences, and in that case experimental probability is very important and very often used. So theoretical probability, we're talking about what we would expect to happen, and experimental probability is what actually happened or what we observed happening during our experiments. So let's look at 2 examples and then you guys can have a go at the ones on your worksheet. So a coin was tossed 10 times and the outcomes are noted there. H for head, T for tail, and they want to know the experimental probability of a tail. Now we know the theoretical probability of a tail. Theoretically, the chance of flipping a tail is 1 in 2 or 50%. In this case, though, it's different. So we did an experiment 10 times, so we had 10 total outcomes. So the probability of flipping a tail is something out of a 10. And we're just going to count here. We've got 1, 2, 3, 4, 5, 6. Okay, so the probability of flipping a tail with this experiment wasn't actually 50%, it was actually 60%. Okay, or 6 out of 10. I've put another question there because this is more kind of what you will be asked in this course. And it says, how many tails would you expect if you flip the coin 100 times? So we've got our probability there. We expect 6 out of every 10 to be a tail. And we're just going to times it by that number there, 100. Okay, so we would expect 60 tails if they flipped the coin 100 times. Okay, going off the experimental probability that we already have. Now, that one was pretty close because we expect chance like that to happen in a certain way. But not everything we're looking at is going to be like that. For example, when we look at people or preferences or choices, there's no 50-50, there's no 1 in 6. We've actually got to experiment or we've got to survey, which is what they've done in this question. So they surveyed TCE students and they wanted to know who preferred netball to football. So there is 10 people surveyed there, and there is 1, 2, 3, 4 people that prefer netball. So our experimental probability, or the probability of someone preferring netball, is 4 in 10, okay, or 25. All right. Now, there are 200 students in the TCE, and they want to know how many people are expected to prefer netball. So this might be for something like enrolments, or they're trying to gauge whether a new program would be successful. So they've surveyed some people and they expect about 40% to be interested, and they want to know maybe how many classes to organise. Okay, that's the kind of thing we're looking at with these. So if there's 200 students and we've got a 4 in 10 chance of them preferring netball, then we want to multiply that by the 200 we're expected to look at. So 40% of 200, oh, this is harder, 10, 20, 80. Okay, so we would prefer 80 students to prefer netball to football. Okay, so experimental probability will normally have the words experiment in it, or it will show you the outcomes of an experiment. Okay, it'll tell you one way or another. Something we need to keep in mind with experimental probability is this probability of preferring netball plus the probability of not preferring netball equals 1. Okay. In this survey, let's say everyone had to choose between netball or football. So if 80 students said netball, we'd expect 120 to say football. Okay, pretty simple. How many people were for it has to be how many people weren't. Now, that is only where they had to choose between the two. If you asked 200 people and they could pick from netball, football, or anything else, obviously that wouldn't work quite so well. But just keep in mind that if you've got the probability of something happening, you can often find out what the probability of something not happening is.